Okay, so now we are looking at our VT graph for the same scenario. So remember, we start off saying this is first of all our VT graph. Our VT graph is all going to be straight or diagonal lines. So I'm going to use my line tool to draw this. So as we go along, I'm going to just think about the scenario. So the first part, we were going at a constant velocity, a nice constant value. So a constant velocity. Positive slope means in the positive quadrant because we're going uphill. Then it slowed down and stopped because remember we stopped to turn around. So I'm going to do a slight slope because we're not going to slow down instantaneously. We're going to slow down and stop so we can turn around because we need to stop to turn around. Then we're heading towards. Remember, as soon as we see towards, we are going below the line. We're moving towards the house again, and we're going to accelerate all the way there. So I want to start off at 0 speed when I was stopped and get to a faster and faster speed to mimic that. Once I get to the house, again, I need to stop because I'm going to stop and pick up my cell phone. So I'm going to show a slowdown, probably a pretty quick slowdown, and a stop, no velocity, none at all. Finally, I'm going to speed up and get to a constant velocity again. Now, we said this is now going to be a faster one, so not only am I going to speed up, but now I'm moving away again, so I'm back in the positive. I also need to consider the fact that my constant velocity needs to be higher than my original one. You'll notice the slopes do match, right? A constant positive slope, a slowdown, stop, no slope, a negative slope, a positive slope back into the positive quadrant. Okay, so our last one is our AT graph. Remember we said our AT graph, I'm going to use the DT graph to guide me because the VT graph to guide me because the VT graph has everything I need to know. First thing I'm going to do is I'm going to label it. This is my acceleration time, and I'm going to use my VT graph as my guide. It's going to tell me what to do. These are all going to be flat lines. So first I look here, constant velocity, no acceleration. So down here, no acceleration, 0 acceleration, no slope, no acceleration. Negative slope because I slow down to turn around. So a negative slope, a negative acceleration. Excellent. So then I have no slope again. So up to no slope, no acceleration, right? No acceleration, no slope. Because I stopped. There's no acceleration when you stop. Then I'm going to go towards and speed up. You'll notice this is a downwards negative slope. So again, I've got a negative acceleration because it's downwards and it's negative. Now here I've got a positive slope, so a positive acceleration. That's when I slow down to stop. So I slow down in my house. I stopped though, so then when I stopped, I'm back to no acceleration because I stopped to pick up the phone. Positive slope, a positive acceleration, and back to no slope. Now this can be really confusing, right? Because there's a lot going on. But here, constant velocity, I slowed down, I stopped, I sped up, but towards, I stopped, I sped up, back to a constant. It makes sense. It all matches the velocity time graph.